We'll continue again, of course, integrals and the integrals of rational functions. Also, I want to give you reduction formula. And let's start with this example, integral x to the power of 4 e to the power of minus x del x, okay? And let's generalize this integration with the integral x to the power of n times e to the power of minus x del x, okay? And now our question, okay, reorganized to the what is the I4, okay, because when you put 4 into the n value inside of the integral, you will find the up integral, okay, and which is x to the 4 times e to the minus x del x, okay, and let's solution I sub n equals to integral x to the power of n e to the minus x del x, okay, and let choose u by x to the power of n, and of course this is a polynomial function, and the del u over del x will be equal to n times x to the power of n minus 1, I'm sorry, and the del u equals to n times x to the power of n minus 1 times del x, okay, and the second part, and the del v equals to e to the minus x del x, so that v equals to, okay, minus e to the minus x, okay, and then continue. I sub n equals to u times v, okay, that means minus x to the power of n times e to the minus x, okay, and the minus, okay, integral v time del u, and it is minus e to the minus x, and the del u is n time x to the power of n minus 1 del x, and the I sub n equals to minus x to the n times e to the minus x, okay, and the plus n times integral, okay, x to the n minus 1 times e to the minus x del x, okay, and what can you say this part integral? You can say this can be written, okay, by the I sub n minus 1, okay, so reorganize with this plus n times, okay, and the I sub n minus 1, okay, and now this is reduction formula, okay, and now we can easily solve the I sub 1, I sub 2, I sub 3, and also which was our solution I sub 4, okay, and the I sub 1, it is equal to minus x to the, okay, 1 e to the minus x plus, okay, and the n times n is 1, of course. I0, it's equal to minus e to the minus x, okay, times x plus 1 plus c1, okay, and the because of we know that I0 is 1, okay, and after that I2, I sub 2, okay, minus x to the power of 2 times e to the power of minus x plus 2 times I sub 1, okay, it equals to minus e to the minus x times x squared plus 2x plus 2 plus c2, okay, and the I sub 3 sorry, minus x cube times e to the minus x plus, okay, 3 times I2, okay, and we know that I2 is here, okay, and the minus e to the minus x times, okay, and the x cube plus 3x squared plus 6x plus 6 plus c3, which is the integration constant, okay, and the I4, okay, and the minus x to the power of 4 times e to the minus x plus, okay, and the 4 times I sub 3, okay, it equals to minus e to the minus x times, okay, x to the power of 4 plus 4 times x cube plus 12x squared plus 24x plus and the 24 and the plus c for integration constant, okay. This is our solution for I sub 4 by using the reduction formula. Okay, and let me continue with the inverse substitution. X equals to a sine theta, okay, so we can say theta equals to, okay, inverse sine x over a. Similarly, x equals to a times tan theta, so theta equals to inverse tan x over a, and x equals to a secant theta, and the theta equals to inverse secant x over a, and also you can call it the inverse cosine a over x, okay, it's same. And let me continue first one, which is the inverse sine substitution. And the square root of, okay, a square minus x square, okay, and we can say that we assume that a is larger than 0, okay, and the x equals to a sine theta, and we said that the theta equals to inverse sine, okay, x over a, right? And let's draw the right triangle and the theta angle here. So opposite side is x, okay, and the hypotenuse is a, and the adjacent is a square minus x square, okay, and the x is larger than or equal to minus a and less than or equal to plus a, so that we can say for theta is larger than or equal to minus pi over 2 and less than or equal to plus pi over 2. So square root of a square minus 8x square, it equals to square root of a square times, okay, and the 1 minus, okay, sine square theta, okay, sine square theta, right? And because of x equals to a sine theta, okay, and it equals to square root of a square times cosine square theta, okay, and it equals to a times cosine theta. So cosine theta equals to square root of a square minus x square over a, and the tangent theta equals to x over, okay, and the square root of a square minus x square. Example: evaluate integral 1 over 5 minus x square to the power of 3 over 2 del x, and the first sketch the right triangle, okay, and that is the theta, okay, and this part is square root of 5 minus x square, okay, and this part is x, so here will be square root of 5, and let x equals to, okay, and the square root of 5, okay, and the sine theta. That means sine theta equals to x over square root of 5, okay. You will assume that from here, because of 5 minus x square equals to 0, so x square equals to 5 and x equals to square root of 5. So you must choose, okay, x equals to square root of 5 times sine theta, okay, it comes here, and after that del x over del theta will be equal to square root of 5 times cosine theta, right? And after that integral 1 over 5 minus x squared to the power of 3 over 2 del x, okay, and the del x was square root of 5 times, okay, cosine theta del theta, Okay, and the numerator part will be equal to 5 to the 3 over 2 times, okay, cosine cube theta, okay, and the 1 over 5, because of here is the 5 to the power of 1 over 2, and then simplification you will obtain 1 over 5, okay, integral 1 over cosine square theta, okay, so it will be 1 over secant square theta, I'm sorry, secant square theta, L theta, so it equals 1 over 5, okay, and the tan theta plus c, so integral 1 over 5 minus x squared to the power of 3 over 2, okay, del x, it equals to 1 over 5 times, okay, and the tan theta equals to x over square root of 5 minus x squared, plus c. Okay. And continue with the another inverse trigonometric function, which is the inverse tangent substitution. And the square root of a square plus x square, or 1 over x square plus a square, and the a is larger than 0. When you find like this form, okay, you can use the inverse tangent substitution, okay, and the x equals to a times tangent theta, so theta equals to, okay, inverse tangent, okay, x over a, and our right triangle now theta x over a, and the square root of a square plus x square, okay, and the example, evaluate integral 1 over, okay, square root of 4 plus x square del x. As you see in the denominator part, we have just found x square plus a square form, so we can use inverse tangent substitution, okay, and let x equals to, okay, 2 tangent theta, and the del x equals to 2 secant square theta del theta, okay, and the integral 1 over square root of 4 plus x square del x equals to integral, okay, 2 secant square theta, okay, del theta over 2 secant theta, right? And let me simplify it. This part will be cancelled, and after that our integral will be secant theta del theta and it equals to ln of absolute secant theta plus tan theta plus integration constant, and the ln of, we know that secant theta is 1 over cosine theta, so cosine theta equals to a over square root of a square plus x square, and the inverse this equality you will obtain ln of, okay, square root of 4 plus x square over 2 plus x over 2 plus c, and ln of square root of 4 plus x square plus x plus c, okay. And maybe we can explain this part, okay, and maybe, okay, let me some reminder, okay, and this part will be 4 times, okay, and 1 plus, okay, and tan square theta, right? When you put x equals to 2 tan theta, okay, you will obtain this. And after that, you can say it's equal to 2 times, okay, square root of 1 plus, okay, sine square theta over cosine square theta, right? And after that, it equals to 2 times square root of, okay, and 1 over cosine square theta, right? And so it equals to 2 times 1 over cosine theta, so it equals to 2 times secant theta, okay, and it comes from here, okay. Example, evaluate integral 1 over parenthesis 1 plus 9x square close parenthesis to the power of 2 del x, okay, and what will we do now? And we have just found again, okay, and a square plus x square, or a square plus u square, maybe you can think about it, because when you choose u equals to 3x, okay, and after that everything will be, this is u square and this is a square part, so we can, okay, use the inverse tangent substitution, and again this is theta, okay, and after that 3x 1 and square root of 1 plus 9x square, and the let 3x equals to tangent theta, so okay, del x equals to secant square theta over 3 times del theta, okay. So that 1 plus 9 x square equals to, okay, and the secant square theta, okay, because of the 1 plus tan square theta, it equals to secant square theta, okay. And they continue, integral 1 over 1 plus 9x squared to the power of 2, okay, del x, it equals to 1 over 3 integral, okay, and the secant square theta over secant square theta to the power of 2 del theta, okay, and the some simplification, this part will be clear, and the equal to 1 over 3 integral cosine square theta del theta equals to 1 over 6 times, okay, theta plus, okay, sine theta cosine theta plus c, okay, and the one over 3, okay, theta is inverse tangent 3x plus 1 over 6, okay, and the 3x over square root of 1 plus 9x square times 1 over square root of 1 plus 9x square plus c, and totally 1 over 6 inverse tangent 3x plus 1 over 2 x over 1 plus 9x square plus c, okay. And let's continue with the inverse secant substitution. Square root of x square minus a square, and now when you solve like this form in denominator part of integral, you can apply this substitution, and the right triangle theta square root of x square minus a square, and this part is x and this part is a, okay, and the x equals to a secant theta, and the theta equals to inverse secant x over a. Example: I equals to integral del x over square root of x square minus a square, and the a is larger than 0, okay, and evaluate this part. And what will we do? Use the right triangle, theta equals, and the opposite side x square minus a square, and this side is a, and the hypotenuse is x. So x equals to a secant theta, and the del x equals to a times secant theta tangent theta, okay, del theta. And after that, square root of x square minus a square, it equals to square root of a square secant square theta minus a square. So it equals to, okay, a times square root of, okay, tan square theta. So it equals to a times tan theta. And when you put these blue rectangles inside to the integral, and the square root of x square minus a square, so it's equal to integral a secant theta tan theta del theta over a times tan theta, and this part will be cancelled. So integral secant theta del theta, so it equals to ln of absolute secant theta plus tan theta plus c, and the ln of secant theta is x over a, okay, because of 1 over cosine a, okay, and the plus square root of x square minus a square over a. We have just evaluated these values from the right triangle, okay, don't forget them, plus c, and the ln of x plus, okay, square root of x square minus a square plus c. Because of from the denominator part we will obtain, okay, this part minus ln a, and we know that a is larger than 0, so ln a will be larger than 0, okay, and when you add the c integration constant, your value will be like that, okay.